My name is Shriram M Chauthaiwale. I am lecturer in mathematics in senior college in the town Yavatmal near Nagpur. I am going to present a paper on a study of algorithms in Karanisadvidha. As we know, Bhaskara introduces himself as a famous shloka Rasaguna Purnamahi Samashukar Samaye Bhavonamopati Rasaguna Varshena Maya Siddhanta Shiromani Rachita. That Rasa means 6, Guna is 3, Purna is 0, Mahi is 1, and Ankana Mamatogati Niyam comes under consideration. It becomes 1036. So I was born in Shaka 1036, and then I scripted Siddhanta Shiromani at the age of 36. Maya Rasaguna Varshena Siddhanta Shiromani Rachita, as he is saying. 4 parts of Bhaskara, many times repeated. In the Bijganitam, there are 2 introductory verses followed by 187 verses related to algebra and 9 verses in epilogue. Total 198 verses. Bhaskara himself admits that this script is compiled by selecting notable ideas from predecessors like Brahmagupta, Sridhar and Padmanabha and others. This is true when we find the frequent use of the terms like Dvikarani, Trikarani, Tritiya Karani in Shurva Sutras and the value of elementary operations on Karanis. In Brahmagupta Sputa Siddhanta, I am purposely saying Brahma Sputa. It is not Brahma Sputa, it is Brahma Sputa. Brahma Sputa Siddhanta, Brahmagupta discuss 6 operations in 3 verses. The 6 operations are addition, subtraction, multiplication, division, square and square roots. In Ganita Sara Sangra, only 1 verse is available which gives operation on addition and subtraction. Shripati in Siddhanta Shikhara gives 6 operations in 5 verses. And as we know, the works of Padmanabha and Sridhara are not available yet. Bhaskara elaborated on these 6 operations in the chapter number 4, Bijganita. The title of the chapter is Karanisadvidha. Shad is 6. This chapter contains 16 verses, 7 algorithms, 9 Uddeshaka as is called, or illustrations or examples. The term Karani is well explained by the commentator Krishna Devanya when he says Tatra yasya rasher mule apekshite parantu nirakram mulam na sambhavati sa karani. That is, quantity of which square root is expected but not possible without a remainder is called Karani. So, though the translation of Karani is usually surd or irrational number, it doesn't carry the total meaning in which Bhaskara used the word Karani. Then Karanisadvidha is explained as Mula Rashor Vargadvara Yat Shadvidam Tat Karani. Shadvidamiti means 6 operations performed with squares of square root quantities are termed as Karanisadvidha. About this paper focuses on these 16 verses and reveals some incorporated algorithms and solutions. Here algorithms are generalized to the rational numbers. And then new examples in addition to those stated by Bhaskara are introduced to explain the extended scope of the algorithm. Some technical terms are always used, out of which avargam for square root, swahata for varga, and yogaja, which were written in red marks, are the uncommon words used otherwise. Then these word numerals, Shabdanka as it is called, are used in these 16 verses, like Ishu for 5, Rutu or Ardava for 6, Siddha for 24, Danta 32, etc. Now, this first algorithm is explained well by 2 of the speakers, so I skipped that. But one thing I want to say about this, the word Mahati. Why Bhaskara used word Mahati, a greater term? For all values of x and y, x plus y will be always greater than 2 times root xy. And that's why for x plus y, Bhaskara used a term Mahati, and for 2 times root xy, Lagu. Otherwise, there is no question of using the term like Mahati and Lagu if that is not the case. and this guarantees that the values give the positive term under a square root. If this is not the case, Mahati and Laghu, then under root of z1 plus z2 or under root of z1 minus z2, especially under root z1 minus z2, there will be always question whether under root z1 minus z2 is positive or negative. If it is negative, then there is no question of getting the root of that. But this value x plus y greater than 2 times root xy always guarantees that such thing will not happen. 3 examples are given by Bhaskara for this. 3 kashtamittayo root 2 plus root 8. 3 bha sankhyayo, bha is 27 nakshatra, and 3 saptamittayo. I am interested in that the third example. Here in this, throughout this chapter, Bhaskara always gives us an example and then says a precondition whether the answer exists or not. And this is a classic example, that root 3 plus root 7. Bhaskara says that pruthak sthiti syat yadi nasti moolam, means while finding the sum or a difference of Karanis, if that root xy does not exist, or in other words, if x into y is not perfect square, then addition is not possible. And exactly that is what happening in the case of root 3 plus root 7, where product is 21, which is not a perfect square number. So Bhaskara says pruthak sthiti syat, means answer of root 3 plus or minus root 7 will be root 3 plus or minus 7. Just only that, addition not possible, subtraction not possible. Of course, we used to say today that only like such can be added or subtracted. That is what we used to say today. As an illustration, I have selected one example where the rational numbers are used in place of the natural numbers. The answers obtained, root of 6 upon 7 plus or minus root 24 by 63. By Bhaskara method, xy becomes 64 upon 49, which is a perfect square. So sum and subtraction exist. And respectively the answers are 150 upon 63 and 6 upon 63. For multiplication, no specific algorithm is given. Only examples are there, that root 3 plus root 5 V3 Ashta Sankhya Gunakaha and Gunyaha 3 Sankhya Sapancharupa. And the second example is V Pancharupa 3 Arkamite Gunakaha. Multiplicand is same, multiplier is changing in both cases. V Pancharupa is minus 5, Arka is 12. Then this is not surprising. Why Bhaskara has not given any algorithm for multiplication of Karanis? Only because in earlier chapter Varnashadvidham, Bhaskara make a very specific comment that a multiplication of algebraic numbers, their squares and their Karanis apply the method of what is called a Khanda Gunana Vidhi discussed in Lilavati. Khanda Gunana Vidhi means multiplication by parts. The method already discussed in Lilavati for numbers, same applicable to Karanis. So he has not discussed this. Now about the division, as earlier speaker pointed out, fourth method of division is nothing but today's rationalization method. So we will go to the next part of our discussion. Now this Vishlesha Sutra is a specific contribution of Bhaskara to this particular chapter. What he has done earlier is root x plus root y, how to find whether it exists or not. Now he is saying how to split a given Karani into two parts, means given root z difference of that, and that term he used for it is Vishlesha Sutra. He is saying us to select a rational m whose m square divides x, and then find y equal to x upon m square. That was the first step he is saying. Then split that m into two parts, m1 and m2, such that it is either a plus or minus for any rational number m1, m2, and then find its square, tadiya krutaya, that word gives that m1 square and m2 square part. Purva labdhya is multiplied by earlier term, y into m1 square, y into m2 square, and then we get an answer for root x into two parts, under root of y into m1 square plus or minus under root of y into m2 square. And the condition is, if m2 is positive, we take a positive sign for the answer. If selected m2 is negative, While splitting m into two parts, then my answer will consist of a minus sign in between that split. One illustration is, I have created that illustration for root 28. This example is not given in the book, in the script. Root 28 can be split into two ways as seen on the screen. One way of selecting m square equal to 4, I get y 7. That m equal to 2 is written in two parts, 5 and minus 3 first, and then 1 upon 3 and 5 upon 3. And then root 28 can be expressed in two different ways, as root 175 minus root 63, or root of 7 upon 9 plus root of 175 upon 9. Again, negative sign is selected only because in first case m2 is minus 3. Now algorithm for square of the Karanis. Again, when he is not giving any algorithm for multiplication, he is not supposed to give it for the square. But a very specific and very special comment is made by Bhaskara about the square. He says that ekadika sankalitam with karani khandani vargarasho syuh. Means he is saying that how many terms will be there in square of a karani. Means if I have n karanis or n square root like root a1, root a2, root a3 up to root an, I want to make it square. Then he is giving the answer for how many terms will be there in that square, and that answer is ekadika sankalitam idani. Eka adhika sankalitam. Means in our today's world, it becomes, if there are n terms for a square, then n into n plus 1 upon 2 terms will be there in the square. Further he explains that out of that n into n plus 1 by 2 terms, I will take a very simple example. If there are 4 terms, I will get 4 into 5 upon 2, that is 10 terms in the square. But out of those 10 terms in the square, naturally each term of the type root a1 square will give me rational number. So in all, I will get root ai square and root ai square terms, and then remaining n minus 1 into n upon 2 terms in that square will be of the type square root of 4ai aj, I less than j, of course, always. Now that discussion can be summarized in a current notations as under root a1 plus a2 plus root a3 whole square equal to, it will be a summation of ai types terms from I equal to 1 to n, and then again summation of the terms like square root of 4i aij. The example selected gives the idea. Root 3 minus root 7 plus root 5 whole square. First, all terms are rational, 3 plus 7 plus 5, and remaining 3 terms will be minus sign only because root 3 and minus root 7 is there. So it becomes minus root of 4 into 3 into 7, then plus and then minus term, giving the final answer required. Bhaskara given 4 examples for finding the squares. First was root 2, root 3, root 5, v trik pancha pramita tasam kruti. Then root 2 plus root 3, then shat pancha v trika sammita 2, 3, root 5 whole square, and then ashtadasha ashta tvik sammita root 18, root 8 and root 2 square. Answers can be found out easily. Now the most elegant part of this chapter was algorithm for the square root. Now I consider for simplicity the expression e on your screen. I want to find the square root of that e. Expression e equal to r plus or minus root k1, root k2, root k3, etc. m terms. And I want to find square root of that. Of course, this expression is not given by Bhaskara. This is just for explaining what Bhaskara is trying to say. While finding the square root of such expression, remember I am not factorizing it, I am finding the square root of this expression. First condition stated by Bhaskara is how many number of terms, that how many number of Karanis should be there in the expression. If that number is 1, 3, 6, 10, 15, again that type, n into n plus 1 upon 2 type, then only square root of such expression exists. Otherwise, Bhaskara said that while observing the expression, we can say whether the square root exists or not. See the example. I have selected 5 plus root 24, root 63. There are only 2 Karanis, and by observing the term that there are only 2 Karanis, I will declare that first condition is not satisfied, so square root not possible. That is what Bhaskara is saying when he said that first see how many Karani terms are there in the expression. Then the first term comes, he says that out of the available Karanis, he is saying to select a proper number of Karanis for further expression. And that criteria for selection is like this. Varge Karani Tritaye Karani Vidyasya. Means if there are 3 Karanis, select 2. If there are 6 Karani Shatake, then Tisrunam means we will be selecting 3 Karanis. Dashasu Chatusranam. If there are 10 Karani terms, we will select 4 at a time. Tithi is 15. So if there are 15 Karanis, we will select out of them 5 first. And then I have given it in a table like that. 1:1, no trivial case, but 3, 2, 6, 3, 10, 4 and 15, 5. Now what is the general rule for this selection? Can be take, I have to remember otherwise every time. There are 15 terms, then I have to select 5. So instead of remembering it, one can solve a simple quadratic equation generating out of it. And then, again this rule is not stated by Bhaskara. It can be but deduced from what he is saying. That general rule is under root of 8m plus 1 minus 1 upon 2 terms are to be selected out of the given x Karanis for further operations. And again, if root 8m plus 1 is not perfect square, just say example m equal to 2 Karanis as what we have said. I will get root 17 and I will declare that square root does not exist. Then second condition is verify that the condition 2 is satisfied. What is that condition 2? Even after selecting a correct number of Karanis, that difference r square minus selected number of Karanis should be a perfect square number. Again, if this is not a perfect square number, then na satvapi, root does not exist. Rupa krute procham padam grahyam chet anyatha na satkvapi. Means if that difference is not a perfect square, then square root of it does not exist. For this, Bhaskara gives a very interesting illustration. That Chaturguna, Surya Titishu, all are the again Shabdankas translated to, if you are expert algebraist, then tell the square root of expression with 13 as a rational part Vishwarupa, and square of Karanis 12, 15, 5, 11, 8 and 6, each multiplied by 4. Chaturguna, Surya, Tithi, Vishu, Rudra, Naga, Rudra, respectively 12, 15, 5, 11, 8 and 6. And that comes out to be E equal to 13 plus all that 6 terms. Even though here first condition is satisfied, 6 Karani terms are there, R equal to 3, M equal to 6. That difference 13 square minus, if I select 3 Karanis out of that, 48, 60 and 20, then that difference comes out to be 41. And again Bhaskara wants that because the difference is not perfect square, square root of E does not exist. But what is the beauty of this example? There are 6 Karanis and 3 Bhaskara is saying to select at a time. I can do it, or anybody can do it in 6C3 ways. If I take a combinations of 3 terms out of 6 available, then it becomes 20 combinations. One I have selected, but remaining 19, if you try to select, then again, every time the difference is not perfect square. And that is the beauty of example. To create such example where all combination fails to give a difference not perfect square is nothing less than the genius. Anybody cannot do this. That all 20 combinations will not give a perfect square number. Condition 2 not satisfied, so goes. Then comes a step 4. And that was a simple step. Once that difference we get y square is a perfect square, add and go further. You will get the required root. But after finding the answer, again this is the new thing which I at least found it, and this is a perfectly a model rather way of giving a subject a correct idea, because after giving an algorithm for square root, now he is saying confirm your answer. Don't go by the answer which you are getting by the said process. And then he is saying to confirmative test for that. We will be going to that. Step number 4 is r plus y upon 2, z2 is r plus y upon 2. And then answer for the square roots are respectively these. Those confirmative tests, yes, I will be coming to that, because the rest part is the calculation part. First confirmative test after getting the answer is given in the shloka. Select a lesser value out of which you obtain, multiplied by 4, and then if that 4 into z2, I have selected z2 as a lesser value, if that 4 z2 divides all the selected Karanis, then only our answers are correct. This is to be tested at each stage of the answer. Because remember, if I have 6 Karanis, my answer will have 3 Karanis. So every time I have to test whether the answer I am getting is correct or not by this confirmative test number 1. For this also, he has given a very special example. Bhaskara's specialty in this chapter, at least what I find, is every time he is giving a counter example or a example to prove what he is saying. The example tells me that the expression I will get out of that Dasharupa is rational 10 and Karanya Chatur Gunita Tithi Vishwa Hutashana, means 4 multiplied by 15, 13 and 4. I will get an expression E equal to 10, root 60, root 52, root 12. Now he is asking us to find the root of this. First 2 conditions are satisfied. I will move to that. I get the value of the roots as z1 equal to 8 and z2 equal to 8. Now I will test whether the answers obtained 8 and 2 are correct or not. 4z2 is equal to 8. But this 8 does not divide 52 and 12 earlier selected. So confirmative test fails, even though we got the answer by procedure. Here Bhaskar has given an example where after getting the answers, we failed to test confirmative test as a correct one, and Bhaskar declares that square root of it does not exist. Second confirmative test, after when first confirmative test is applicable, is given in the next verse, where he says each quotient obtained after division. Okay, 4z2 is divisible, but each quotient obtained after division must appear in the answer. If not, then again the square root does not exist. For that, again Bhaskar has given one example: 10, root 8, root 56, root 60. Find the square root of that. Dasharupa, Karani Trayam, 3 Karanis, Ashta, Shat Panchashata and Shashti. That means root 8, root 56 and root 60. Again, when I start solving, 2 conditions are satisfied. I get the answer Z1 and Z2. 4Z2, 8 divides my selected Karanis, 8 and 56. So up to this stage, preconditions are satisfied. Confirmative test 1, okay, it's true. Up to this step, everything goes fine. Now he is asking us whether second confirmative test is true or false, and that second confirmative test is that 1 and 7 must appear in the answer, that those quotients 1 and 7 must appear in the answer. But we observe that confirmative test 1 holds and the answers are root 2, root 3, root 5. But our quotients are 1 and 7, and those quotients 1 and 7 earlier obtained do not appear in the answers obtained. Root 3, root 2, root 3, root 5, but root 1 and root 7 in particular is not available. So again Bhaskara declares that confirmative test number 2 fails. So again expression E has no perfect, it is not a perfect square, or square root of that expression E does not exist. Now a very interesting thing. all the illustrations which Bhaskara has given earlier, all the expressions Bhaskara has, all the illustrations Bhaskara has given, he has given positive values for Karani. No plus root 8, plus root, nowhere negative sign is used, even in the illustrations. But he remarks that if positive and negative square root Karanis are available in that, then what should we do? What should we do? Dhanatmikata parikalpa sadhya. Consider them as a positive value, follow the procedure, and last warning after following the procedure is how to write an answer. Because if I have minus root 8 in my original expression, then square root must contain at least one term minus. Then how to change which term is minus? For that, Bhaskara has given a very, cute answer. Sudhiya avagamya. He is not saying anything less. He is saying Sudhiya avagamya. Judge from your side and decide which of the answer should have minus sign and which of the answer should have plus sign. One example for that I have selected for a illustration with some minus terms there, minus root 68, etc. That goes and gives the answer finally like this. Answer for that expression 34 plus root 64 root minus, etc. Now see what will happen. Once I complete, I will get 4 plus minus 6 plus minus root 11 plus minus root 7 and plus minus root 10. And that is factorial for 24 answers I will be with me once I complete the procedure. But out of those 24 possible answers, Bhaskara is exactly saying Sudhiya avagamya, intelligently select the correct answer, and those correct answers are given in the blue. Now the last thing, Brahmagupta and Shripati stated different methods for addition or subtraction as compared to Bhaskara. Later Narayana compared all the methods. Concept of that Yogaja Karani and that Vishlesha Sudra is a unique contribution of Bhaskara. For division, multiplication, square and square root, Bhaskara followed Brahmagupta and Shripati, no doubt about that. But Bhaskara is the first scholar to discuss preconditions, limitations, confirmative test for correct extraction of the square root. So, on observing all such discussion, we must say that Jayatu Bhaskaracharya. Thank you.
Regarding the search or the Karani, would you illustrate the historical background of the search? Is whether the Bhaskaracharya is the first one who has actually coined the term Karani, or how? Can you elaborate it?
Yes. I cannot elaborate it, but I can show you one, two tricks which I have shown you earlier. Bhaskara was the first, not the first person to use this. We know value of root 2 up to 4 decimal places from the period of Shulva Sutra. Concept was there. What Bhaskara did, compiled the work, modified and completed. After Bhaskara, nothing remains in this field. So you have to track the history of that Karani or Satta from Shulva Sutra to Bhaskara. But Aryabhata uses the same Karani terms many times. Every mathematician uses those Karanis, but the operations elaborated by Bhaskara, especially for square root, are the latest ones.
Chapter on Karani, finding the square root. 6 examples have been given to us. Correct? The first and the 6 only have solutions. The rest, I think, is showing.
Yes. He is showing that the conditions are not satisfied. Yes.
Are they different examples?
Yes. All are different. All
are showing different limitations.
Different limitations. Actually, what I have done is I have changed the sequence of that verses so that I can elaborate the things. Actually, what he has done, he has given seven verses as an algorithm and 9 examples, one by one. But I have selected When I say this is a condition, I select an example to give that condition, clear that condition.
My work is on Karanisadvidha.
Yes.
He has not taken up all the examples. So I only, when I went through Bhaskara's example, I put the second, third, fourth, they could not resolve it. Why they can't resolve it?
Only because those conditions are not satisfied.
That's right.
As given earlier. What he is doing is giving the condition. He is not giving him the conditions first. He illustrates the example first and then say the condition. This condition is not satisfied. That's why the example is not correct. Nasab he is saying Nasab after quoting the example. Thank you very much.